But welcome back, everybody. Great to see you all once again. As I said, it's the final workshop. Sadly, the series has come to an end, but we're adding all of the recordings to the Hacker Pack, so I know you have a nice little summary there and lots of content for you to look back on. And what better way to finish it out with the Movement Labs team? We have 2 members joining us today as well, so a special treat for us all to finish off, and really excited to have Jordan and to have Andy here joining us today. So I think they're going to split the presentation. They'll be active in the chat, so feel free to ask your questions there too. I'll do my best to shout out anything which I notice in the chat as well, and hopefully between the 3 of us we'll manage to cover everything. But that's everything from me. I hope everybody enjoys it, and Jordan, I believe I'm handing to you to get going.
Yeah, I appreciate it, Rory. Yeah, saving the best for last, right? but yeah, how's it going, everybody? Jordan, I lead the blockchain advocacy here with Movement Labs. And from a small town called Freeport, Florida. Been doing engineering work for about 4 or 5 years. I'm also accompanied with Andy G. I'll let him introduce himself.
Hi, everyone. I'm Andy Golay. I'm a solutions engineer and DevRel for Movement Labs, and really excited to be doing this hackathon for featuring building on EigenLayer with Encode, and I come from like a web entrepreneur and like building, getting my hands dirty type of background, and I can't wait to see what the hackers build in this hackathon.
Awesome. So yeah, so let's go ahead and get started, right? Let me see if I can get my slides going on. Perfect. So we'll just kind of start off going over a little bit of like what Movement Labs really is. And really our mission, I would say, is we're essentially building a modular framework that builds and deploys move-based infrastructure applications and blockchains in any distributed environment. So just like a quick overview, so essentially Movement is like the first integrated blockchain network that powers the fastest and most secure layer 2 on Ethereum. So by bringing the Move virtual machine to Ethereum through our novel MEVM, ZK layer 2 technology, we're creating essentially the most secure, scalable, and developer-friendly blockchain infrastructure that essentially combines the best aspects of modular and monolithic architectures for speed and safety with the Move language. So with our tech stack, we essentially have 3 different components. So we have M2, M1, and the Move stack itself. As far as M2, it's essentially the first parallelized Move EVM layer 2 on Ethereum. And it essentially combines the speed and security benefits of Move with the backwards capability of existing EVM protocols. And as far as M1, it's a fully decentralized and speed optimized shared sequencer. So M1 provides the Movement network with reliable uptime, optimized finality, and embedded interoperability as well. And it also comes with the built-in verification. And this essentially enables the sequencer to serve as a watchtower for any incoming attack vectors. And lastly, we have the Move stack, which is an execution layer designed to scale the rollup on Ethereum, regardless of what rollup framework or data availability layer that the network chooses to leverage. And feel free to scan this code and fill out the form and everything. But I would say outside of like our tech stack, our vision is very much community centric. We aim to be a very community blockchain. We believe in empowering developers and their projects to flesh out whatever dream project they care to build, right? We very much believe in utilizing security and modularity through our Movement tech, obviously. I would say that Movement was born with really a simple but yet like powerful idea, which is making the Move programming language accessible across like entire modular blockchain ecosystems. And I guess you may be asking like, why Move? I would say like Move, it's very easy to adopt, right? It derives from Rust. And I would say most importantly, it's very much security by design. So I know that everyone's seen all the hacks that have happened just within the last few years in crypto. And since I've been in back in 2020, like it's been insane to see, right? It's been like billions of dollars worth of exploits. And we truly do believe for institutional adoptions, we need more secure, languages as well as infrastructure in place. So with Move, you essentially have like a strong static type system and built-in formal verification, just to name a few of the security features that really help reduce some of the most common vulnerabilities associated with what plagues the industry today. And with that being said, though, like we do believe the ability to build anywhere on Movement, right? So Movement does provide like a flexible and versatile platform, which essentially enables developers to deploy across various modulars and layers. So really, you can choose between whatever language when using our tech stack. So we're not just subjected just to Move. With that being said, you can essentially use different versions of Move. You can switch between different features and integrate various aspects to your developer stack instead of having to potentially learn all the tools and frameworks associated with each. You can kind of just pick and choose what fits best with your developer needs. So even though we're all obviously very big proponents to the Move language, I would say that we also very much give Solidity devs love as well. For instance, you're able to actually deploy Solidity contracts utilizing your tech stack onto the Move EVM, for instance, through Fractal, which acts as like an interpreter, which I won't get into the weeds about. But essentially, you do have that flexibility there either way to leverage those skills as well. So I would say that's kind of like a high level overview of, Movement Labs and kind of some of our tech. I'll make sure to kind of throw into the chat some additional resources that you guys can look into. With that being said, I'll go ahead and kindly pass it over to Andy G. He'll go over a few dApp examples on how to integrate our tech stack with EigenLayer. So definitely feel free to take the stage in.
Nice. Thank you, Jordan. I see Andy's already sharing nice and quick. I'm just going to maximize Jordan's screen quickly one last time, just so anyone who hasn't scanned the code already, make sure you scan it. And then we will move on to Andy's presentation. Sorry for that, Andy. There you go. You can have your screen back now. And equally, I know Jordan's going to drop some links as well in the chat. So whilst Andy is going through all of the examples, feel free to open those up on a second screen and take a look over the content some more. And of course, feel free to ask your questions in the chat and we'll do our best to get those answered for you. So, Andy.
All right, so I wanted to show an example of something you could build, for an AVS. We noticed, like, for another AVS hackathon, there was like 100 participants, but no one had submitted anything yet. And my personal theory is that maybe it has to do with people not, necessarily understanding what an AVS is, or how to build an AVS, or how to build with AVSs. And so I wanted to give a little dive into the tech. This is a draft of a blog that I'm working on to go along with this example, but it's just sort of it's something that I think can help us understand, like, if you're a builder and you want to get a stab at some of the prize money and you're like, okay, how do I build something relevant with AVSs? First of all, you want to understand what an AVS is. So it's a system that requires its own distributed validation semantics, which, if you think about it, that could be like just a blockchain, like Bitcoin or any blockchain is just, a distributed validation system. Semantics meaning that it just has its own special language for...
Sorry to jump in, Andy. Do you just want to maximize your screen? We can see your entire screen. So if you want to maximize the tab.
Oh, yeah. Yeah.
There we go. It's just a bit clearer. Thank you.
Okay. Yeah. So like an Oracle network is an example of an AVS, data availability layer. Like for example, EigenDA, which is the flagship AVS provided by EigenLayer, and just virtual machines, keeper networks, just different cryptography schemes. It's just anything where you could use an extra validator network, and like some kind of system like for validators validating some kind of computation or result in a distributed way. So the way EigenLayer works is summarized in this diagram pretty well. So there are contracts deployed on Ethereum. Like these different AVS contracts have what's called a service manager, which is an interface for the EigenLayer protocol. And then they have other service contracts that do specific things, for their specific AVS. And EigenLayer itself has core contracts for their AVS directory and like delegating everything that they do just as a layer in itself. So I put a link there. You can look at EigenLayer's resources. So some AVSs require an off-chain layer, not all of them, but like off-chain computation is a great example usage for an AVS. And the AVS contracts hold the state relevant to the service's functionality. So there's, you can get into EigenLayer itself and how it uses the strategy manager where stakers deposit their assets, and delegation manager lets stakers choose which operators to delegate to. And operators are just basically validators for the specific AVS, and they're staking ETH or some other asset so that they are playing with skin in the game as they do their validation for the AVS as operators. So we're going to look at sort of modifying an example for a basic, like super basic math example that EigenLayer provided, which is something called incredible squaring. So they have documentation and some videos overviewing it, but their GitHub repository is here. It's under Layer Labs and then Incredible Squaring AVS. They have instructions for, let me just make this a little wider so I can see all my tabs and then still have a full screen view. So they have instructions for how to run their AVS, and then I created a modified version here. So at github.com/AndyGolay/EigenLayer AVS examples, where we have just some modifications. So like, first of all, we want to be able to run an AVS. So to run an AVS locally, you need to have 3 terminals running. So an Anvil chain, which is just like it's Foundry's tool for spinning up a blockchain. So I have this repository open locally here, and I already just did this make start Anvil chain with EL and AVS deployed. So you can see there, it's just advancing the blockchain. It's just producing blocks. And then you need the aggregator. So make start aggregator. And so I'll start a new terminal, make start aggregator. And what the aggregator does is it sends tasks to the it sends tasks to the operator, like it says here, aggregator sending new tasks, number to square 0, 1, and you can look at the incredible squaring code base to see how that happens. I could get into it a little bit here if we have time. Then the third agent that needs to be running is the operator. So the aggregator sends tasks to the operator set, and then the operator agent picks those up. This happens on chain through the aggregator contract, and the operator we can see gets registered, and then we have a transaction for including the operator, and then we're funding thanks to how EigenLayer set up this incredible squaring repository. So I think for hackers, like what a good strategy could be is like modify the incredible squaring AVS to do some kind of really interesting kind of operations. So like, let's see what our aggregator is looking like. And yeah, so the aggregator is receiving signed tasks now that we have the operator going. You know, once we started the operators, we could we can see that the aggregator gets a threshold reached. So that's the idea of an AVS. Is it's like you have this computation that's happening somewhere. So like, let's see. So the number squared is 81, and then last digit of block hash is 0. So in the incredible squaring example, you'll have like this is the 9th task. You see it says reference task index 0x9, and then so the number that the aggregator sent to the operators is 9, and then in the incredible squaring AVS built by EigenLayer, the number squared that was returned by the operators as a received signed task response was 81. But excuse me, there's also last digit of block hash, which is returned basically for block 9 of the movement blockchain, which is the thing that I added in. So I'll show you the modified code there. Let me check the chat just to see if there are any questions about.
I was just going to jump in, so good shout. Somebody's asked whether validators choose to participate as a validator for an AVS or whether it's guaranteed.
Yeah, exactly. I from what I understand, validators can opt in to AVSs, and then they put whatever, they select whatever their stake is that they want to put it as at risk for their participation as operators for an AVS. But yeah, it's definitely, as far as I understand it, it's all opt-in. Is movement an operator here? Well, this is all like testnet or like even DevNet type of things. Like even this incredible squaring example, just to like kind of lower the bar in case you're like, I can build an AVS. Like this incredible squaring example by EigenLayer is actually configured for just one operator. So like even this is like very experimental, just doing their basic examples. So EigenLayer, I'm sure, is like happy to have people build on them, and like it doesn't need to be like production ready, or even like the tokenomics. Like you don't need to worry too much about like is movement operating it, is anyone else operating it? Because like right now we just want to see developers like build something interesting. Yeah, so I hope that answers your question, Katya. All right, so just getting into the code a little bit. Okay, that's how to run an AVS in general. So just an introduction to AVSs. And again, like I kind of suspect that a lot of hackers are stuck on that main idea of like, what is an AVS? So I hope that cleared it up. Like any blockchain or any sort of distributed service is pretty much an AVS by definition. But what EigenLayer's done is they've created tooling to build AVSs really conveniently and intuitively in a way that sort of recognizes them for what they are in a formal way. So shout out to EigenLayer there. So as far as modifying an AVS, all right, so the actual, the contract will be in Incredible Squaring Task Manager .sol. So we can look there. That's going to be in under our source directory, src, and we can see just what happens. There's a task, and then they send the number to be squared. In the, let me see if I can, there we go. Yeah, so one thing you'll see in the contract, the task manager contract is logic for, wait, let me see if that's in, oh, okay. Yeah, there's sort of a quirk in their contracts. They have this one that with two eyes in the beginning of it, incredible squaring, and then you just want the one with one eye. So the logic of checking whether a challenge is valid or not is done by just literally checking, they define a variable called actual squared output, and they take the number to be squared that they sent to the operator and they multiply it by itself. And then they check whether or not the actual squared output is equal to the response that they got from the operators. So in the task manager contract, like that's something, if you want to allow challenges in your AVS, that's something that you're going to want to modify. I asked the EigenLayer team, and they said you only need challenges if you're going to have some sort of slashing clause in your contract. So I think generally for a production AVS, you will want to consider that. You might want to have maybe like a ZK fraud proof, or that could be an opportunity to show off some creativity in terms of your sort of security know-how or your ability to check some kind of results that are more interesting than just a mathematical result of squaring a number. So that's one thing that you'll want to change as you modify the contract, specific for an AVS that you're building, if that's a route that you go for the hackathon. And then the main thing, as far as the actual workings of the AVS, is this operator.go file. So the off-chain agents are written in Go lang. So there's different directories here, like we have the aggregator is one agent that, if you want to see how all of this is working with the aggregator sending out numbers, every 10 seconds it sends out a new number to square. And like what I did was I modified it to take a block hash from Movement Network, one of our devnets, M1 devnet. So if you go to the operator directory and then check out the operator.go file, and then compare it to the incredible squaring default example, which just has code for squaring a number, which, let's see, yeah, which I think I commented out there. And then like now what it does is, so when we run this operator, we have all this set up, and it's like a lot of boilerplate provided to us by EigenLayer. But in this example, what I do first of all is define a block struct, which allows us to ingest block data as we query it from Movement blockchain. And then we have, so this process new task created log is the function that's sending these logs back to the aggregator. So you can look into this and just like how it works for AVSs in general, but I wanted to give an example that queries just something about Movement Network. And, you know, of course, you'd probably want something more interesting like querying a contract. But in this case, we have in the process new task created log function, we do, we call get last digit of movement block hash for the specific block height, which you can see here, block height is just the number to be squared that the aggregator is passing in. So we're going to square that number, but we're also going to just do something a little more interesting, which is we're going to call get last digit of movement block hash. And you can see how that function works. Down here, we're doing an HTTP GET request by block height. We're using the semantics from Aptos REST, the Aptos API spec. So our upcoming testnet is using Aptos Move as the base Move language, and we're using the Aptos API specs. So that's something good to get familiar with if you're building on Movement. So here we're querying the block by block height. And so we just get it, we get the block information, and then we get the last digit, and you can see how that's all done in the code there. So instead of squaring a number, you're taking a last digit of a block hash, which in a sort of simple way could be used as a random number generator. And then if you wanted to get even more interesting, like you could deploy a contract to Movement, like this voting system from Move Developers DAO. And that's another example you could get into. You can imagine like calling a function to double check how a vote went, and there's just a lot of really interesting examples that you could get into.
Yeah, I was gonna let you know that we got just a few questions. That one repo is up to date, right, Andy?
Okay, yeah, I guess I have to push some local changes to that. Yeah, okay, I'll do that right after. Sorry about that. Yeah, I was just setting up my GitHub connection on my local computer when I was putting that together. So yeah, within the next hour or two, you should be able to see the updated changes.
And just a reminder, Arjun, all of these will be recorded. So once that's updated, if you want to run through this again with the updated repo, then that should absolutely be possible. But otherwise, I think that's it for the questions. There's one from Satya about the threshold notion. Is it the quantum threshold percentage?
I I think it's just what the specific threshold is for the AVS. In that case, it's just that AVS is configured for one operator. So I think just when that one operator returns a signed response, it just will meet the threshold. But you could configure an AVS, I think, with any threshold that makes sense for your use case.
Awesome. I think that's it for now, but I'll shout out if I see any others.
All right, cool. So yeah, so I feel like I should update that repo. Is there I don't know if we need to go in a more specific example, or if that's like, like the idea with the voting system one could be, instead of using the like blocks by height, and querying that way with a get, what you could do is you could view, like you could take this voting system and maybe add a view function, because I don't think this one has a view function. Like you could add a view function to this voting contract that Aptos move by example has provided, and then you could use the view to be able to execute the view function, and then the AVS could double check election results, because oftentimes with votes you have this idea like, yeah, the election result is on the blockchain, but still it's like you want some way of checking what's on the blockchain, and most regular people might not be equipped to just go and query the blockchain directly themselves. So using a service like an AVS could be helpful to let you verify the results of an election, like whether it's like doing sort of a snapshot of when the vote was initialized, who are the candidates, when votes happened, and then the declaring the winner, like when that happened, and just like double checking that all of that was done correctly, I think could be a really interesting project for this hackathon. And I actually know a developer who's working on this too. So yeah, so that's something that is just, yeah, I think it's very relevant. And yeah, if anyone wants support building something like that, or any sort of NFT type of things, like maybe verifying the authenticity of an NFT, like with using so maybe checking a Merkle root, or like some kind of ways of verifying ownership of digital assets. That could be another really good use case for an AVS that's being used to interact with movement. And you could get really creative, like implementing things with EigenLayer AVSs in Move, which that sort of is a whole nother thing. It's going to be kind of like implementing something like EigenLayer in Move. But I think just if you implement like an AVS that's really interesting to you, then that could be awesome. Yeah, Manu, we should have the blog. Okay, great. Jordan says it'll be launched today. Okay, awesome. Okay, great. Yeah, I'd like to get these out. So
perfect.
Awesome. So I'll update the repo in the next hour, and then we'll have the blog and a video overview for AVSs for resources for devs hacking.
Awesome. Is that everything in terms of your run through, Andy? Am I okay to remove your screen? Perfect.
Yes.
Cool.
Thanks.
Well, yeah, thank you very much for that. Obviously, lots of ideas there for everyone here in terms of what you might like to build for this hackathon. I know some of you might have some questions afterwards as well. So I've just dropped a link to the movement zone. We've set it up on the EigenLayer Hackathon Discord server, which we've made. I know Andy's already in there. So if you have any follow-up questions, you're welcome to head over there to ask anything about that. Jordan, I know you've just dumped a bunch of links there. Do you maybe want to talk through them just to explain where people can head and what kind of resources are available?
Yeah, no, absolutely. Again, yeah, I just dumped a few resources, and I can also put it in the Discord channel as well for you guys, because obviously, like, this is gonna probably go away. But yeah, so we have the movement hack right here, the first link. That's just more of like a hands-on, just how to, navigate through our tech stack. The dev docs, that kind of provides, again, some more step-by-step tutorials on how to navigate our tech stack. And it also provides more thorough information as far as what our tech stack consists of in general, right? And data room, that's like everything Movement Labs, right? That's again, like, you can kind of find, like, top accounts that, tweet or write about Movement Labs and what all that entails, in-depth information on our tech stack in various regards on Notion. Yeah, so just basically like the go-to for all information with Movement Labs. I also above, and I'll gather up all these links for you guys, but I did also share the QR code as well. And yeah, I believe that's all the links we have so far, but.
Amazing. I know you shared the QR code as well of where people can find out more and get in touch. Where is your community most active? Where would you kind of point people to if they want to get more involved with what you're working in?
I would say for sure Discord. Our Discord is very active. We have like various specific chats for devs, as well as like anyone else who wants to get involved in our ecosystem in various capacities, whether it's technical writing, content creation, etc. I can also get that link for you guys as well. But that, I would say, is the most active point of contact.
Awesome. And then there's a question here. Maybe it's one that you need to go back and confirm, but maybe you can provide some insights. Obviously, there's mention of the grants in your bounty. How do they work? Do you want to expand on that now, or would you rather come back and put a proper answer together?
Yeah. I mean, I can go like high level into that. Let me just pull that up on my end real quick. But essentially, in regards to the grant, I mean, we do pay in USDT or DC, whatever of your choosing. And we also prefer, or we also are going to, airdrop another token. Wink, wink. Can't talk about what that is, right? But that's a little bit of a surprise. And we do also offer additional grants for the future as well, to further continue development of Movement Labs.
And then there's a follow-up question there about what kinds of projects would be eligible, or perhaps what kind of projects you'd be particularly excited to see. Is there anything in particular that you might encourage people to explore and start building towards?
Yeah, Andy, I mean, maybe you can answer that a little bit more. As far as voting, I mean, I was even thinking you can implement that into like some sort of like SocialFi front end. Like maybe you can have a front end SocialFi type project, whether it's like Twitter/X, whatever you want to call it, right? I still like to call it Twitter, but and have like some sort of like voting mechanism there would probably be super interesting, kind of experiment. Yeah, I'm not sure if you have anything else, Andy, but that's just something off the top of my head that would be an interesting idea.
Well, yeah, that could be good. Also, just like the more you can use Move, the merrier. It's like the concept of an AVS is sort of a very generalizable thing, and it's implemented right now through EigenLayer, and it's So you have a couple different routes you could go. You could create an AVS that works really well with the EigenLayer and somehow interacts with movement, or maybe you even have move contracts that somehow work as part of the operator set. But also you could think about implementing an AVS in Move. It's with an AVS focus, it's like you want to be thinking about what's a type of system where I would need like validators to sign and risk some sort of economic penalty if they're giving false information. So you could be a game that involves an AVS, because one thing is I just showed the aggregator. Let's see, am I still running it? No, I guess not. But it's like the results come in from the operator, and I just showed it in the command line. But you could build a game, or you could build like some DApp. Like you could build a front end that consumes that data coming in, and like that to me would be like a finished product that would be really cool to contribute to movement. Something that it's ingesting the data from the operators and using it in a way that end users can interact with. So whether you're into gaming or SocialFi, it could be a chat DApp where you just double check that messages were sent from who they were supposed to be sent from. Like maybe you double check that people who have some sort of access pass to a specific chat were able to indeed chat, because like supposedly these things really work. Like there's an NFT gated community, and like supposedly only people with NFTs are able to chat in those communities, but there's no one really like as a watchdog. Like to me, these AVS systems could be like a watchdog to just double check that like, yes, this NFT gated community is legit. And like, again, like anyone who's tech savvy enough could check it themselves and verify this information themselves. But who's really doing that? Like as far as end users and mom and pop users, they're going to probably rely on some other trusted service like an AVS. So to me, that's like, that could be used in SocialFi, gaming, DeFi, anywhere where you want like another network to just verify or double check some kind of results is something that jumps out at me.
Awesome. Well,
yeah, we also, sorry not to interrupt, but we also have some projects as well with those chatbots as well. Like if you want to maybe even experiment with that, and we can also send those links over. We have it in Move and Sui Move. So.
Perfect. Well, I think that answers your question, Arjun, and I'm sure you can't ask for much more than that. There's so many ideas and things that you could then build out. So I know this has been super useful for anyone looking to build their projects, and has hopefully planted the seed of what you all might like to build. So thank you very much to both Jordan and Andy, and obviously thank you to all our participants as well for joining us, asking your questions, not just today, but for all of the workshops. So I don't have too much more to add myself. Perhaps Jordan, Andy, maybe there are some final remarks or things you'd like to share before we wrap things up.
Yeah, no, it was a pleasure, you hosting us, right? It's definitely been great working together, and definitely look forward to see what you all build.
Perfect. Andy?
Yeah, I'd say just like remember, like it could be a good opportunity to just flex your dev muscles. It's like, don't worry too much about like whether this is going to be the killer dApp to like change the world. Like just think like, maybe this is just a good opportunity to like get your hands dirty. And like I just put the chat dApp in there for you, Arjun, and we'll be in Discord at the dev chats popping. We have a lot of people just chiming in there, and we're really looking forward to supporting you. And I'm in the Encode chat. I think Jordan's probably going to join as well in the what's it called, the move zone.
Movement zone, yes. It's in the EigenLayer Hackathon channel, which everyone will have access to. And then there's a dedicated room for you all to ask Andy and Jordan any questions you might have. Of course, they've shared a ton of links today, so you're welcome to take those conversations wherever you like. But it's a good starting point for you all to direct your messages. And I'm sure Andy and Jordan will be on hand to answer those for you.
Yeah, and we'll post all the new updated links and educational material and the updated repo with the actual modifications I made in it today as well. So thanks, Rory.
Awesome.
Appreciate you.
Well, let's wrap things up there then. Thank you very much. If anyone needs anything, whether it's movement, post it in the zone. These guys are there to help you with that. If you have any questions about the hackathon, of course, you can DM me to it's Rory Encode on Discord. But otherwise, thank you for joining us. Good luck with your projects. And thank you one last time to Jordan and Andy for a great workshop. Thank you very much.
Thanks everyone in the chat too. This was a great chat during this.
Cheers.
Bye-bye. All right. Cheers.